Okay, so question 2a asks us to find an antiderivative of this function, which is 1 divided by 3x minus 4. Now there's a little trick in maths that if we ever are asked for the integral where we can identify that the derivative of the bottom is on the top, so g dashed x is divided by g of x dx, then our antiderivative, our solution to this problem, is going to be the natural logarithm, log e, of the absolute value of g of x. So just that bottom part of the function there comes in here. Alright, so going back to our function, let's have a look at what's going on. So we have that we're trying to find the integral of 1 on 3x minus 4 dx. It's not exactly the derivative of the bottom on the top, because the derivative of the bottom would be 3. So what we can do is we can remove that factor of a third from out the front of the integral. So I'm going to write this as 1 on 3 by the integral of 1 on x minus 4 on 3 dx. So now we can see that this inside bit here matches what we wanted to find up here. So we can push this through and we get that this is equal to a third by the natural logarithm of the absolute value of x minus 4 on 3 plus c, where c is an arbitrary constant. But for our case, we're just asked for an antiderivative. So we can let c be any number we want. So I'm just going to let it equal 0, which means that the integral, the answer to this question, is just a third of the natural logarithm of x minus 4 on 3, and that's it. So question 2b asks us to solve the following equation for x. Now hopefully you can recognize that this is kind of like a quadratic. So we've got, you know, some terms here and some constant terms multiplied by them, and finally just a constant term out here. So let's start by getting this all onto one side of the equation and letting it equal 0, because then we have a chance of solving it via the null factor law or using the general quadratic formula to do it. So let's do this by going 4x minus 15 by 2x minus 16 equals 0. Alright, now I'm going to be a bit cheeky and I'm going to take this 4 here and I'm going to convert that into 2 squared. And that's still obviously to the power x minus 15 to the 2x minus 16 equals 0. Now I'm going to let a equal 2x, because when we distribute this guy through, I'll just do it over here, we get that 2 to the power 2 times x is equal to 2 to the power 2x. So by letting a equal 2x, we find that we can rewrite our, what I was boasting before was a quadratic expression, into this. So we let a equal 2x, and we get that this quadratic can be rewritten as a squared minus 15 times a minus 16 equals 0. So now this is definitely a quadratic, or I hope you'll agree with me that it is. So we've got a couple of methods that we can use, is that we can factorize or use the general quadratic formula. So I think I'll do both for you just so you can see where you can get your answers from. So if we factorize, this one's pretty easy. So we just place a on the left hand side of both the brackets, and then we just need to play around with some numbers to put in here and here until we get what we want. So what we want these numbers to do is we want them to multiply to give negative 16, this term here, and we want them to add to give negative 15. So we want them to add to give negative 15. So let's go ahead and list the multiples of 16. So we might have negative 1 and 16. We might have 1 and negative 16. We might have 2 and negative 8. We might have negative 2 and 8. We might have 4 and 4. So 4 and negative 4. And then that's about it from what I can see. So then we just need to go through and see what these guys add up to give. So we'll add them up and we'll evaluate them. So this guy up the top gives 15. That's not going to work because we want negative 15. But luckily, this guy does give what we want. Just to complete this, we'd get that'd be negative 6, that'd be positive 6, and that'd be 0. So we select the one we want. And we drop that in here and in here. So we're going to have plus 1 and negative 16. So then the null factor law, I'll just put my next bit of work in this box here for you. So the null factor law states that if A times B equals 0, then A equals 0, or B equals 0, or A equals B equals 0. So in our case, we've got that A plus 1 equals 0. Therefore, A equals negative 1. And we've got A minus 16 equals 0, or A equals 16. I'll just need to grab a little bit more room to do my working now. So I'll get rid of this. Hopefully you can look back at the video if you need to see what was going on there. Alright, so now we've got a little bit more room. So remember back at this stage here, we said that we'd let A equal 2x. So now we can substitute that in to say that 2x equals negative 1, or 2x equals 16. Now if you remember much about exponential functions, you'll know that they kind of look like this, where that would be 2 to the power x, that blue curve. So as you can see, they're never actually negative. The other way we can do this is we can take the equivalent log statement. So we take the base of the power becomes the base of the log. The answer is the argument, and the other bit sits in the other spot. So we know about logs as well, and we know that logs are only defined from not quite 0 to infinity. So a log graph would look like, in green, this guy here. So as you can see, we can't have a negative number, so this guy here is not defined. Our 2x equals 16 on the other hand though, so coming back to here, is defined. We've just got to find the point along here at which point we have 2x equals 16. So to do that, all we've got to do is we've got to make 16 be 2 to the power of something. And then we can just equate our x's. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the power 4 is 16. So we can just say that x equals 4. Now the other way we could have tackled that is, again, we could have used the equivalent log statement. So I'll do that in green. So we're going to go from here and we're going to go back into the equivalent log statement. And we're going to go log of 2 of 16 equals x. And then we can just use our plog rule, so which says that we can move a power from here out to the front. So we could have effectively got log 2 of 2 to the power 4 equals x. Then if we move the 4 out to the front, we're going to get 4 log 2 of 2 equals x. Oops, sorry, x. And log 2 of 2 would be 1, so we just get 4 equals x. But personally I like to use this method where I can. It's a fair bit quicker as well, as you can see.